Hello, welcome to DAT314, running Apache Cassandra workloads using Amazon Keyspaces. My name is Arturo Hinojosa, and I'm a Principal Product Manager on the Amazon Keyspaces team. With me today is Mihir Desai, one of our Senior Solution Architects. During today's presentation, we're going to talk about Amazon Keyspaces by providing you a quick overview of the service. We'll talk about its service architecture, the benefits of Amazon Keyspaces, as well as provide a recap of the launches for Keyspaces we had over the last year. Then Mihir is going to talk about how one of our customers, PricewaterhouseCoopers, is using Amazon Keyspaces to store its data for one of its applications. Before I start getting into Keyspace, let's start off by talking about Apache Cassandra. Cassandra is a very popular wide column open source data store. And it's really good for large scale applications that require very, very fast read and write performance with very low latency. For example, managing all of the user profiles in a social media application, or storing the device metadata for IoT apps, or it's like sorting all the messages or transaction history, any sort of event logging where you're writing lots and lots of data very quickly. Cassandra is really, really good for those use cases. And one of the reasons developers like Cassandra so much is that it offers a very familiar developer experience. So for example, if you're used to using Postgres or MySQL and writing SQL queries, select star from table, you can bring a lot of that knowledge and experience with you to Cassandra and Keyspaces using a very similar syntax called CQL, or the Cassandra query language. So in Keyspaces or Cassandra, you would just say, hey, select these columns from this keyspace.table, and you specify some conditions for the partitions you want to search. So again, it's very familiar, very similar, so you can get up and going very quickly. However, despite its really, really good developer experience and really scalable architecture, there's still challenges with Cassandra. A really cool, interesting study from the Apache Software Foundation earlier this year found that 36% of practitioners of Cassandra say that lack of knowledge about Cassandra is inhibiting adoption within the organization. So that's almost 1 in 3 really, really smart people about Cassandra saying, hey, the fact that we don't all know more about Cassandra is meaning we can't use those skills for more workloads and to get the most out of our Cassandra knowledge. And there's a few reasons for that. First and foremost, it requires really specialized expertise to deploy, configure, and manage the software. You have to have very deep knowledge and low-level knowledge of Cassandra, Bloom filters, compaction strategies, as well as the operating system as well, right? How to tune the Java virtual machine. All these things to make Cassandra get you that really fast performance are things you have to know as a developer, right? Usually as a DBA, but with Cassandra, you really own that as a developer. In addition, it's very hard to scale down Cassandra clusters. We've talked to a lot of customers that they are basically sized for peak load year round. So if you're a rideshare company and you're basically sized for midnight on New Year's Eve, on a Tuesday in the middle of February at 4 o'clock in the morning. You have very different passenger load at that time, but your infrastructure can't scale down. So you're paying for those same resources at both of those moments in time. Version upgrades in Cassandra are also very hard. It's hard to go from version 2 to version 3 because of its clunky rollback features. We spoke to a lot of customers that tried, a node misbehaved, they had some sort of availability dip, so they just basically abandoned the project. I think there was a study a couple of years ago that found that half of Cassandra deployments out there are still running version 2 and half are on version 3. I think it's a little bit more on the version 3 side these days based on our customer conversations, but you can sort of see, these are versions of software that are years old. Right? So moving and upgrading is very, very hard. In addition, Cassandra doesn't offer a lot of built-in enterprise features. For example, you have to restore every single node individually. You just can't restore a table or a particular record, and it's very error prone. Because you have to go node by node in your cluster, restore each individually. So a lot of customers just say, heck, I'm just going to redeploy the cluster and reload everything because they don't have that fidelity for backup and restore. Cassandra also doesn't offer any built-in encryption features. So if you're a healthcare company or a financial services company writing, an application, you want to use something like a patient's social security number, or you want to use an account number as the partition key, you can't encrypt those in Cassandra, right? That's just not a good security best practice. And then finally, Cassandra is deployed in a cluster with nodes, right? And you're going to be tens, hundreds, or thousands of nodes. And that's a really big responsibility you're signing up for to manage all that infrastructure if you want to use Cassandra for these large-scale enterprise workloads. So as a result, we had a lot of customers say, hey, AWS, can you help us run our Cassandra workloads more easily? Can you give us a better way to just run Cassandra so we can just write great applications and write great data models and start using this powerful, data store features without having to worry about all the underlying infrastructure and managing that infrastructure? And that was the motivation behind Amazon Keyspaces. We built a scalable, highly available, and fully managed Apache Cassandra compatible database service. Keyspaces is production ready for mission critical operational workloads today. It's generally available in 20 AWS regions. We've offered a lot of built-in enterprise features such as backup and restore, data encryption. It's also deployed in a highly available configuration by default. We also offer a 4 nines availability SLA within an AWS region for the service. And then finally, Keyspaces is integrated with a lot of AWS's other services. Right? You have those deep platform or deep AWS cloud integration, such as CloudFormation, CloudWatch, all those tools that you use to monitor and make sure your workloads are running at peak performance. All those sort of come out of the box with Keyspaces. So let's take a little bit a deeper look at the service architecture, right? To begin, if you sort of think about Apache Cassandra, you kind of start off with this node, and you deploy one or more nodes in a cluster. Really nice scalable architecture, really good for serving lots and lots of reads and writes per second, so you can sort of scale horizontally. And with Keyspaces, we sort of wanted to take that really nice scalability and that really good developer experience just to make it easier to use. So again, we start off with Apache Cassandra, the 3.11 version of Cassandra, and we took advantage of Cassandra's modular architecture to really reimagine how we could offer Cassandra as a fully managed serverless offering. So first, we integrated it with some of the AWS services, right? Like we integrated with AWS IAM to provide authentication service. Now you have those fine-grained access management policies to decide who can and can't access a particular key space or table. But we also reimagined how storage would work, because this is really one of the big pain points of Cassandra, right? Tombstones, like compaction strategy. These give people nightmares. So we kind of said, hey, let's leverage our learnings from building other massive scale global non-relational database services, and let's bring those learnings with us to Amazon Keyspaces. So as a result, we really reimagined how the storage nodes would work. So when you zoom out on the service architecture, now you have this really nice, massively scalable, highly available service architecture with this fleet of Keyspaces nodes, brokering requests tied into this service or storage node backend that's highly durable, storing multiple copies of your data across multiple AZs, and that it gives it the same consistent performance at any scale, which has got a lot of nice benefits for customers, right? First, because we are running Apache Cassandra, it's compatible with Apache Cassandra. Your CQL code, your developer tools like CQSH, all those work with Amazon Keyspaces. Keyspaces is also serverless, so there are no servers to manage, no software to maintain. You sort of get rid of all that underlying management and maintenance infrastructure that you don't want to spend your time doing, especially as a developer. Finally, or not finally, but next, that really massively scalable architecture gives that same single-digit millisecond read performance at any scale. Whether your table's got 5 writes per hour or 1,000,000 writes per second, you get that same single-digit millisecond performance. And finally, you get a lot of built-in high availability and security features, encryption, backup and restore. All those are available with Keyspace with a couple of clicks, or they're just enabled by default. So let's talk a little more about each of these in depth, right? So it's compatibility. What do we mean by Cassandra compatible? Well, it works with the existing CQL code. You can create key spaces and tables, and you can read and write data, the stuff you would expect. Keyspaces also works with a lot of the popular Cassandra drivers and developer tools like CQSH, DataStax Bulk Loader. We even offer step-by-step instructions on our website that walk you through setting up the Java driver, the GoSQL driver with Amazon Keyspaces by changing a few lines of configuration. To your clients, Keyspaces looks like a 9-node 3.11.2 Apache Cassandra cluster. It's basically indistinguishable. That means your drivers just have to support Cassandra 3.11.2 and they'll work with Keyspaces. It also means Keyspaces is backwards compatible with in the same way that Cassandra 3.11.2 is. So if you got some CQL code that you run in your Cassandra 2 cluster or 2.x cluster, odds are it's going to work with Keyspace because we offer that same backwards compatibility as Apache Cassandra 3.11.2. So when a client connects, right, all you have to do is, again, change the service endpoint or the cluster URL in your driver configuration with the service endpoint for Keyspaces in whichever region you want to use. And when you connect, your driver is just going to see a Cassandra 3.11.2 cluster. It's going to be pretty much indistinguishable. Now, there are some differences between Keyspaces and Cassandra. There aren't a lot of low-level APIs for things like Bloom filters. You're not going to find those in Keyspace because it's a fully managed serverless offering. We also chose not to support the deprecated Apache Thrift API, so you will have to use CQL. If you are thinking about moving your existing Cassandra code from Thrift to CQL, it's an excellent time to consider going straight to Keyspaces. Getting a more modern solution, serverless, etc. there are benefits for you, lots of benefits for you in that regard. We also didn't choose to prioritize experimental or features with known scalability and durability issues. Things like aggregators, materialized views, indexing. It doesn't mean we won't do those in the fullness of time, but those things really aren't production, or those features really aren't production grade, mission critical workloads today. So we didn't want to offer something in the service which wasn't designed for these massive scale workloads, right? So we are thinking about how to do these things better. If we can, we'll try to contribute those back to the open source project as well, so you'll benefit from those in Keyspaces as well as in Apache Cassandra. Now, I think one of the biggest differences between Keyspaces and your traditional vanilla Cassandra is the fact that Keyspaces is serverless. And I think for a lot of existing Cassandra customers, they actually don't know what that means, right? I mean, yeah, there's the obvious stuff. It's serverless, so there are no servers to manage, so software to deploy, maintain, or operate. All that stuff sort of goes away. But you also have to really fundamentally rethink what you're using, right? So there is no cluster, there is no nodes, there's no more compaction and tombstoning. You don't have to worry about the JVM or garbage collection. All those things now fall below the waterline. For you, now, instead of the cluster and the node being sort of your fundamental building block, it becomes logical stuff, key spaces and tables. What data does my application need? What queries do I need to write? How do I want to organize that data? That's where you start. Not with, hey, what instance size do I need to go to deploy to go install Apache Cassandra? All that stuff now is below the waterline. Because Keyspaces is serverless, we also offer a serverless resource management, right? So storage auto scales, you pay for what you use, we automatically scale up and down based on the data you write and delete from your cluster. And even on the read-write side, you have two choices for how you want to manage that throughput capacity for your tables. The first is on-demand capacity, where you basically say, hey, AWS, I want you to fully manage capacity for me. I want to set it and forget it button. This is really good for new workloads or workloads that are very spiky. We sort of take on all that capacity management for you. The other option we offer is provision capacity with auto-scaling. And provision capacity with auto-scaling is really nice for predictable workloads where you sort of know what your traffic is going to look like. Because if you share that information with us, we're able to manage our infrastructure behind the scenes a little more efficiently and pass those savings on to you. So you can help, which helps you optimize for price for your more predictable workloads. So how should you choose, for which was right for you? Again, think about it. On demand is really good for new or very spiky workloads. Capacity is fully managed by AWS on your behalf. You can basically scale up to any previous peak capacity instantly, and you can even double your peak capacity every 30 minutes. So it's, again, for these big events where, hey, we've got a big product launch, we don't know how much capacity to expect. You can use on-demand mode for that day because you can switch back and forth between the two once per day. But for your sort of vanilla days where you sort of know what your traffic's going to look like, you can say, hey, Keyspace, or hey, AWS, I know my upper and lower bounds are here. I want to maintain our utilization around 70% because I want, in case I need to scale quickly or scale down. Well, again, we can do that for you, but again, provision capacity is probably a better choice for predictable workloads as you can save a little bit of money. That being said, provision capacity does let you auto burst or scale above your provision capacity temporarily. Let's say, for example, you're using Keyspace to store information for a social media network, some celebrity on your site or on your network posts some really interesting news, gets a bunch of traffic to their profile. That's okay. Keyspaces can scale up temporarily by using something we call burst capacity. So basically, burst capacity uses your underutilized capacity for the last 5 minutes to try to accommodate when you sort of burst above your provision capacity for a moment in time, basically until auto scaling catches up. So again, really nice choice of options for read and write capacity. Both scale based on your actual application's traffic. It's just about, do I want AWS to fully manage it for me, or do I want to sort of optimize on price a little bit by sharing some information up front because I know it's a more predictable workload. Now, let's talk a little bit more about Keyspaces performance, right? As we talk about, you get the same single-digit millisecond performance at any scale, whether it's a really small table or a really big table. Keyspaces hyperscalable architecture really just helps accommodate that workload pretty much instantaneously to make sure you maintain that same single-digit millisecond performance. Tables do scale up and down based on actual traffic, whether you're using on-demand or provision capacity with auto-scaling. And one thing that's really cool about Keyspaces is our logical partitions can actually span across multiple physical storage partitions. So the size of a logical partition is actually virtually unbounded in Amazon Keyspace, right? You don't have that 2 billion limit like you do with a vanilla Cassandra, which is nice if you depending on your data models, you can scale to be very large. Keyspaces also offers a couple options for read and write consistency. So for durability reasons, all writes use local quorum consistency. That's sort of the default and the only option. The data is automatically replicated 3 times across multiple AZs. But for reads, we actually do offer 2 choices. So you either can use one or local one consistency, or you can use local quorum consistency. We typically recommend using one or local one wherever possible because you get higher availability, a little bit better performance, and a lower price. So if you don't need that strong consistency, you can tolerate a little bit of that lower consistency. One or local one is really nice choice. We bill one or local one at the half increment double RCU prices compared to one RCU for strongly consistent reads. So again, you have that tunable consistency for reads based on your particular use case requirements for data consistency. As I mentioned earlier, we also offer some really nice high availability features. Data is replicated 3 times across multiple AZs automatically. That 4 nines availability SLA, so that lets you know the service is going to be available. And you can monitor your application performance and availability using Amazon CloudWatch. And the cool thing is here, as opposed to a lot of metrics about cluster health, you're getting a lot of metrics about performance and availability, stuff that you as developers and application owners really care about, right? You can build metrics or dashboards in the console or in the CloudWatch console, dashboards for provision capacity, consume capacity, utilization rates, error rates, all that really important stuff that you need as the application developer. Keyspaces also offers a lot of built-in security features. All data is encrypted at rest by default using keys stored in AWS Key Management Servers or AWS KMS. Keyspaces helps you protect traffic in transit by using TLS for all connectivity. You can also manage access to Amazon Keyspaces and tables by using AWS IAM. We also offer plugins for the Cassandra drivers. You can also use IAM roles with the Amazon Keyspace, which is pretty cool. So you've sort of adopted that sort of newer model, short-term credential security model. You can use that stuff with Keyspaces and with the Java, Node.js, Python, I think Go driver. So really cool options there. You can also connect Keyspaces to resources in your VPC using AWS Private Link, and all the administrative actions are logged in CloudTrail, so you can see who created a key space, who deleted a table. All that stuff is captured for you automatically. You can surf it, scan it, or whatever you need to do in Amazon CloudTrail. Now, this is actually one of my favorite features. Keyspaces also offer something called point-in-time recovery. Point-in-time recovery helps you protect your data from accidental deletions or updates, right? We basically create a continuous backup of your table data, 24/7, and you can restore that table data to any second in time over the previous 35 days. And PITR has absolutely no impact on the availability or performance of your table. It all happens seamlessly behind the scenes. So we really recommend enabling PITR for all production tables. You can choose to enable it just for some tables or all tables, but if you have a production table with really important data, really recommend enabling PITR. PITR is priced based on the size of the table you store. So if you have like a 1 gig table, you pay 1 gig for storage, you pay 1 gig for PITR. And you can even manage PITR using the AWS console if you prefer that, the programmatic GUI, or you can also use the point-and-click GUI, or you could manage PITR programmatically using CQL-SH. We actually extended the CQL grammar so you can manage backup and restore right from CQL, which is pretty cool. So again, that's sort of a quick overview of Amazon Keyspaces and its key benefits and the service architecture. Now, let's talk a little bit about all the stuff we launched this last year, right? Because I know we launched so much stuff, it's kind of hard to keep up. So we always like to sort of quickly provide customers a recap of, what is all the stuff that we launched over the last re:Invent, basically. So, teams been working fast and furious. So we have about a little over 18 launches now year to date. We've deployed Keyspaces in 20 AWS regions, including the 2 most recently AWS regions in China, which is pretty cool. We've also been contributing back to the open source, right? So the whole project's basically right now very focused on Cassandra 4, but we have been contributing things like the open source authentication plugins for those Cassandra drivers I mentioned previously. When you sort of look at our roadmap, right, open source is part of that. There's other sort of 3 big other areas of investment when you sort of look at the last year. One is our top priority is to continue to improve compatibility, adding more Cassandra features, things like ordering clauses, being able to alter tables, counters. We really are adding features based on customer feedback and what customers tell us is more important. We also have been working on trying to raise the bar for the Cassandra developer experience. We recently introduced Apache Cassandra and Keyspace support to the NoSQL Workbench, so you can design data models for Apache Cassandra and Amazon Keyspace using a very nice point-and-click interface. So you can sort of see how do these sort of my query patterns and access patterns line up against my table schema. Really cool stuff. We're really excited about the improving developer tooling. We also plan to contribute back a server-side component to Apache Cassandra, so you can sort of use those plugins I mentioned with even Apache Cassandra and EC2, right? Again, it's all about just improving the developer experience for Cassandra developers, no matter what version of Cassandra or flavor of Cassandra you choose to use. And then finally, we continue to just offer deeper integration with AWS other services and features, being able to view your account quotas in the service quotas console, being able to use tagging to create cost allocation reports and manage access to resources based on tags. PITR, the private link support, all these stuff which sort of help you run your operational mission critical workloads using the breadth of AWS services. We'll continue to add those and invest in those in the service. So with that, I want to go ahead and turn it over to Mihir to talk about how one of our customers, PricewaterhouseCoopers, is using Amazon Keyspace for one of its pretty cool applications. Mihir?
Hello all, my name is Mihir Desai. I'm one of the solutions architect here at AWS, and I will be walking you today through an example of how PwC uses Amazon Keyspaces in their automatic contact tracing application. Before we start, a little bit about PwC. For those of you who are not familiar with the company, PricewaterhouseCoopers is a network of firms that operates under the PwC brand globally. PwC is in the business of providing audit and assurance, advisory, and tax services to various companies. As of 2020, PwC is the 5th largest privately owned company in the United States, and PwC ranks as the 2nd largest professional services network in the world and is considered part of the Big Four consulting companies globally. PwC Check-in. So this is a product that provides a continuous view of the risk of exposure among workforce before and while they're at work. So an action can be taken to take care of the employees and to operate the business with resilience. Amazon Keyspaces is used to support the check-in automatic contact tracing app. This slide is to highlight the key benefits of the check-in app. So it helps manage risk by managing capacity in a particular building, in turn mitigating infection risks. It prevents overcrowding as the product keeps track of employees who are currently in a particular facility. And then check-in provides confidence to employees returning to work under conditions such as the one we're currently in with COVID-19. And the assigned check-in administrator in a client's environment can choose to integrate their existing tools and policies to plan ahead of how they're going to bring their workforce back into the offices. And the collected data helps forecast trends and identify exposure risks that are present with the workforce inside the buildings. This slide explains sort of the 3 layers of the automatic contact tracing app. The front end, or the user portal, right? It is a mobile app that the users can install on their phone. There's also a personal beacon that's available that can be carried around for people such as visitors or guests inside a building. There's a backend. This is where Amazon Keyspaces is used. This is where the data is going to be collected and stored. And we will unpack the architecture of this particular technology in a couple of slides. And then lastly, there is a user portal that authorized users can go into and input a name of an impacted employee, for example. ACT will instantly provide a list of potentially at-risk colleagues who have come into close contact with the person that's been identified. So why Keyspaces, right? Arturo highlighted a few key benefits of Keyspaces. This slide in particular talks about why PwC selected Amazon Keyspaces. So elasticity is the top of the line here. What do I mean with that? So ACT use case requires flexible scalability. For example, during business hours or on weekends, the number of people in the buildings will be significantly less. Keyspaces provide scaling up and down, which reduces operating cost of the ACT solution. Cloud integration was also a key reason for PwC selecting Keyspaces. It provides the monitoring and alerting that is needed along with dashboarding capabilities out of the box, right, integrated with the product. Time to market, this is also important to PwC. If you do not have any Cassandra specific operations knowledge to get started, Keyspaces is a good fit, right? You get access to a Cassandra cluster in minutes, and it simply is an easier alternative to building and managing a Cassandra fleet yourself. Pay-as-you-go model helps PwC. There are no upfront cost, and this provided them with a lot of flexibility and enabled them to be more agile. And lastly, scale. Keyspaces was selected for the ability to process a very high number of writes, up to 200 billion writes a day. So this is the middle area, the backend technology that we were talking about a couple of slides ago. This sort of unpacks the architecture, and we'll spend a couple of minutes going over it, right? So the end user device communicates with the backend in AWS via an input API. Upon ingest of the data through input API, it's put into a Kafka queue for ACT. The Kafka queue is the service called Amazon MSK, which is a fully managed service called Amazon Managed Services for Apache Kafka, which is the full name of MSK. The output of the queue writes the data to Keyspaces, and it is stored in Keyspaces in a time-shard graph data model. A distributed query layer powers the API queries from the output API and delivers real-time results back to the front-end portal. And then data is written and stored across 3 Keyspaces, written to only one particular Keyspaces instance at a time. And this is to comply with the data retention policies of ACT solution. PwC is one of the requesters of an enhancement that we'll talk about in the next slide, of a feature called the TTL feature, which allows the data to be expired automatically without user intervention, in turn deleting it once it's expired. So let's spend a couple minutes talking about lessons learned and feature requests that PwC specifically is waiting for. So truncating tables, right? So this is a workaround that PwC had to put in place for the TTL feature that we just discussed in the prior slide, which is on the roadmap of the Keyspaces team to be coming out in the near future. Amazon Keyspaces supports unlogged batch commands, up to 30 commands in a batch. Only unconditional insert, updates, or delete commands are permitted in a batch, and logged batches are not supported. So this required a little bit of tuning on the application side for PwC. The way the capacity is reported in Keyspaces required an application side exception for handling adjustments. The retry mechanism required a logic to be put in place for the upper retry limits inside the ACT application. So 2 feature requests, in addition to the TTL feature, from these lessons learned that PwC is requesting. So classify the throttling events by reason, for example, by capacity or by hotkey, right? And expose more user-accessible error logs to enhance monitoring and alerting of the system and user logs. And I think that's it. Thank you for attending.